Hi, a very good afternoon to everyone. Am I audible? Am I audible? All right. Can you guys give me a thumbs up if you can hear me? All right, cool, great. So, hello everyone. I'm SAURABH Datta. I'm the Senior Product Manager at Gathr Data, and I've been associated with Gathr since its inception and have been through various roles and responsibilities. Currently, I take care of the product's roadmap. So I kind of prioritize what items should go into the product and envision what features are relevant for the product. Also take care of the R&D initiatives. So at Gathr, we are solving very interesting problems on converting data to outcomes applications for very large organizations who want to really build it fast, really build it very quick for their customers. So I'm going to share one such experience with you today from the financial industry, wherein this is a very important case study for a large financial institution and how they achieved credit card approvals in real time. So what I plan to cover today is I'll go through the background of the customer and the use case, the key expectations from the solution, the major elements and logic that were part of the solution, the tools and the technologies. I'll give you a snapshot of the actual use case. I will try to demo it on our application. And finally, we'll go through all the goals that were accomplished on this platform. So this is like the top credit card organization of the globe. It has currently presence in over 50 plus countries. They have 50 million plus credit cards in circulation globally, and they are planning to add 4 million new credit cards per year globally. So that was the scale at which the organization operates. From a problem statement standpoint, the cards were pushed into the market through various channels, and one of the most important channel was their web portal, wherein people could just go and apply for a credit card using a form. They submit the form, and in the background, there is like a bunch of logic that gets executed. And finally, a decision has to be communicated to everybody who is filling up the form, right? So the idea is to really acquire legitimate and responsible customers so that it is not just good for the bank, but also for the financial well-being of the person who is actually applying for the credit card. So we really want to acquire responsible customers. And there are 3 important decisions that had to be made. The first one was whether to approve or disapprove a card that was applied for. Then if the card was approved, what will be the line or the credit limit that the bank should offer to the customer? This was the second decision. And the third key decision was at what APR or the annual percentage rate at which the card has to be offered to the customer. So this is like the key expectation from the solution. So the bank was really looking at transformation in various areas. And if you look at the bigger picture, the central issue was really the delay in which the credit cards were approved. The process was really slow, and which led to really frustrated customers and potential loss of business and negative impact as well on part of the institution if the respondent or the applicant is not getting the response in time. So the area was to really get rid of all the approval times and meet the expectations of the customers and really provide them the approvals in the seamless manner. Now also there was also again when you bring in this kind of a real-time system in picture, you really expect increased conversion rates because there are no missed opportunities, no customer drops, because the customer really has the credit card as and when they need it. So the idea was to really get rid of all the manual interventions and bring in automation as much as possible, so that the internal resources of the organizations could also be optimally improved and the allocation could be optimized. Now to leverage this kind of an automation, we needed like accurate credit decisions. So whatever cards were approved, whatever limits were approved, they have to be really very cutting edge, and the solution has to be used using all the possible data sources that the bank could collect data from. And the idea was to really reduce the overall assessment risk. Now, this was also important from a standpoint that when there is like competition also available in the market. So when people really apply for credit cards, if you are not right away giving them a decision, they might really move to your competitors. And all the new age financial institutions are leveraging technology, and they are giving people a seamless experience. So even large organizations have to adapt. They can't rely on their old processes. Finally, what was happening was not just on the customer side, but also from the bank's internal perspective, they needed kind of an insight of who is applying, what sort of cards are getting applied. So they needed some insights internally for the bank as well. So it's a combination of the customer experience plus what the bank needed internally. Now, if we talk about the sources of the, for making the decision, there were really like 8 to 10 different sources. I'll focus on a few important ones. The first one was definitely the application form, which the customer was filling in. So it had things like name, address, date of birth, regular stuff that anybody would typically fill on the form. But this was then connected with the data that the bank was collecting from the credit bureaus. So this became like the second source of information. So reporting agencies like Equifax or Experian or TransUnion. So these were the credit reporting agencies from where the bank was collecting the data about the applicant's credit history or payment behavior, if he had any outstanding debts. So these were the information that were collected from the credit bureaus. Then the third source was the identity verification services. So this was again important so that, oops, what's happening? Just restart. I'm sorry. Yeah. So the identity verification service is again important so that you can confirm that the applicant who is actually applying is the intended person. There is no fraud involved and nobody else is applying on the applicant's part. So there are, again, identity verification services which the bank was referring to ensure that the correct user is applying. And then, the last internal source was the internal data. So if the customer was already an existing customer, the bank was checking in for the usage of that existing customer. So apart from these four, there were certain other databases which were onboarded very recently, including the regulatory databases where again rules like anti-money laundering and all those rules are present. Similarly, the public records to check if there are any judgments passed against the applicants and any liens or any bankruptcies that the applicant has filed. So this really reduced the risk on the bank's part. And finally, there are again institutions' internal policies. So this kind of were all the sources that we were typically referring to and processing the data from. Now, once you collect to the data sources, there were certain transformations and processing rules that were applied. And after the processing rules, what came in were the different models. So here on the left-hand side, we have all the three models. For the approve and decline, these kind of decisions, we were using a decision tree model. And based on the geography, the region, there were almost like 120 different models that were being utilized. Then the next decision was again the credit limit. For this, regression model was used, and we'll go through the details. And finally, for the credit limit or the price model, we utilized a clustering model wherein we utilized k-means to actually determine what should be the APR that should be the given. So these are the three important models that were utilized in the credit card approval. So now, if we talk about the first decision tree, so this is again for people who are just new to data science. This is again based on the features that are coming in, the different attributes. You kind of pass through this tree and you make a decision. So just for an example, you start from the top node. Let's say salary is one of the feature. If salary is less than 5,000, you go on one track. If the salary is greater than 50,000, you go on another track. Similarly, if there are other loans, if the credit score is, let's say, greater than 600, so you pass through all the nodes of this tree, and when you finally reach the leaf node, you take a decision whether to approve or disapprove. So this was the model that was used for the approval and disapproval. The second model, the regression model, again, this is good when you have one dependent variable, which is the actual credit limit that has to be provided, and multiple independent variables like the credit score, the location. So based on the independent variables, you kind of try to calculate a score, and then based on that, you get an exact credit limit that has to be provided. And finally, the APR. So based on, again, the data, this is again an unsupervised model. So based on the data, you kind of define all the different clusters. So your clusters are predefined based on the credit score. And then when the real-time data comes in, what you do is you try to map that real-time data point into a particular bucket. So you know that this particular record belongs to one bucket, so probably I'll go for a 16% APR. So that's how all the three models were evaluated one after the other. Yeah. So the proposed set of tools were, again, it was heavily, Spark was heavily used as a solution in the background. So Spark, along with Spark machine learning, and the real-time data was collected on Kafka. All the records that were processed were finally pushed into HDFS, and the real-time records, whatever evaluations were done, were again pushed back to Kafka. So as a user, when I apply on the portal, I get a real-time response whether my card is approved or not in most of the cases. And in some cases where the machine is not able to make a decision and you need additional information, the decision was put into pending state or a deferred state, when then somebody would manually go through all the details and then put in the right decision. Now, if we stitch all this story together, you get a request, you make credit bureau calls, then you try to find out the statement of wallet. Again, this is an interesting case because we have little time. I'll go through it maybe later if you have interest. So there are certain, again, transformations that are being done. And as I said, there is like 120 different models based on the region which gets calculated. All the three decisions are given one after the other, and you finally respond to the client. Now, I'll show you a very small demo. This is like a subset of the real-life implementation that we did. So this was the dashboard, and on the left-hand side, you'll see all the different card categories that the customers were applying to. And on this dashboard, you are also seeing the applications that were done in the last 7 days. Now, on the left-hand side corner, you will see that most of the decisions were made by the algorithm. So all the yeses and nos were made by the algorithm, but the yellow area that you see, these are the deferred ones wherein we need some manual intervention. So by manual intervention, I mean that you could see all the records, and then you could also see the details of individual person. So here a manual person will look at the record, see the details, and then he will actually decide whether to approve, disapprove, or in certain cases actually ask for additional information from the person who is applying. So this was the internal dashboard. So imagine in one platform you have the capability to dashboard, and then we also have something called as data pipelines which power these dashboards. So let's look at the data pipeline dashboard here as well. So all the pipelines are listed over here, and we had something called as a training data pipeline. So in this particular pipeline, you create your use case that kind of reads the data and does all the processing. So once this loads, there is something called as inspection. So this is again an interesting thing. So when you create your features, typically you drag, drop, you play, and then you see how your pipeline is behaving. But we here, what we do is we take a subset of the data and pass it through each operator and each node over here to make sure that the operator is in a sane state. So we verify the sanity of the pipeline. We kind of get a background. And here on the right-hand side, you'll see all the different operators that we have. So we start with the sources. All the operators are listed out here. And similarly, you can drag, drop, and put those operators on the canvas. All the machine learning algorithms are also in place that you could use for training. And finally, the targets where you want to push the data after the records are processed. So that includes, technologies from Amazon on GCP, Azure on the cloud, and for on-prem systems, things like HDFS, Hadoop. So all you have to do is search for the filter of your, an operator of your choice and drag drop. So once that is done, you will then typically start from the data source. Here we have all the operators lined up one after the other based on the logic sequence. All you have to do is either fetch directly from the source where the data is residing. In case you do not have access to the source, what you can do is just upload a file. And once you get the access, maybe then just change it from upload file to actual source. So you start by fetching the source. And we have something called as this I button, which gives you a snapshot of the data live on that particular operator. So what you see is, this is like the application form. So you have things like, an applicant's name, his email address, all the details like age, phone number, the form data you get, you can just, see over here. And then if there are any pre-processing you want to do on that data, you could do it again. Now, if I just dig a little deeper here, the null value checks and all those operators are lined up one after the other. The next source I am simulating was the credit scores that were stored. So here, the credit scores from 630 to 700 and all those bucketing, and the credit status is done. So both these are joined right now, but in the actual use cases, there were around 8 to 10 different sources that we joined together. And then, just for an example I'm giving here is the transformation. So here we are replacing the null values. So you can just click, write an expression. So here for anybody who is not using or not putting in the cards category, we are replacing it with a Sapphire credit card. Another thing that we are doing over here is dropping all the anomalies. So for example, even if the credit score is high, if we have disapproved an application, those anomalies have to be taken out of the model training. Otherwise, the model will also be trained in that fashion, that for high scores, it will disapprove. So any anomalies that you have, all those anomalies have to be cleared out before you put the data in the model. Now, next you do is you use the model, use the training part. Here, it was a classification algorithm, so all you have to do is just configure it. It's a very simple, to use wizard wherein you could do all the pre-processing, what all features would go into the model. You would select that. You would just do all this model configuration. Now, because this is a tree, what is important is you decide the depth of the tree, how many trees you want to train. So all these things, even if you are not a data scientist, all the values will come by default, and all you have to do is just keep clicking on next. And finally, your model, you can specify how you want to break the data between the training and testing part, and how you want to do the evaluation of the model. Everything is pre-fed. Look at the final result, and just, the configuration is finished. Everything is done on the same canvas. So in the way you have trained in your decision tree, similarly, you could use, again, this regression model as well. The configuration, again, is pretty straightforward. Instead of classification, you choose regression over here, the model that you want to use. Just keep clicking on next. The model will be configured. And finally, the APR here, this is, again, a k-means clustering model. So the configuration, I'll just go through very quickly. Give a name. And then, again, in a k-means, what's important is you provide a value of the k, which is the number of buckets that you want to create. So specify the number of buckets. In this case, we created 5 buckets. And all you have to do is just save and run the model. So automatically, the pipeline will fetch the data, apply all the transformations, create the results. And if you have, let's say, in the end, if you want to store the data, it will store the data for you as well. So now, once the pipeline is created, Next, typically you would play the pipeline, and I already have a certain plays done. So what I can do is next also look at the pipeline's history. This is important when you are working in a collaborative environment, right? So you can look at what were the previous runs, monitors. If there are any errors, you could search over here. When multiple people are working, as I said, you could look at the audit activity of who did what, so that you know if there are any changes done, who has made those changes. Now, when the pipeline is run, as I said, the models get registered, right? So there is a specific model repository that we have in the system. All you have to do here is, look at that repository here. We named a credit card request model over here. So this model gets registered. And you have multiple versions that you can maintain over here. So if we just open one particular version, you could see all the details of the model. So you could see the configuration that was used to train the model, which features were important for the model, the metrics. For example, here we are evaluating using ROC. Similarly, the confusion metrics. All this is created automatically. As a user, I'm not doing anything. Eventually, what I want is all these graphs should be, probably do their best. So I just have to look at these graphs, and I could get an idea of what the performance of my model is. Now, similarly, you have your regression and your APR, k-means model listed as well. Let's look at the scoring pipeline. Mostly, the training and scoring pipelines, the initial pre-processing steps will remain the same, except for a few. Just for an example, here, as you see, all the initial steps are same. Instead of generating the credit values or having the credit scores by default, what we are doing is in real time we'll fetch the values from the external agencies like Equifax and Experience, and then we'll push the data into the model. So here, instead of training, just use prediction, and you are good to go. I mean, all your models are the same. Just select your model, feed in the exact attributes that you used for training. Everything is auto-selected. I know I'm going very fast, but I just have 30 minutes to cover, so I'm trying to pack in everything. We have a presence at booth number 400. I'll be happy to discuss in detail with you. But yeah, so what I was saying was, you just configure the operators one after the other, and you could see over here, like, the credit limit. If you do the inspection, I could see the different ranges of credit limit that were provided using this aggregated graph, as well as if I shift to the table view, I could see at an individual record level as well that, what was the credit limit that was provided to an individual user. So once this is done, finally the bucketing is created, wherein each individual record is kind of attached to a bucket. So we have, 5 buckets created, if you remember. And what I'm doing next is, based on the bucket, I am assigning a percentage to it. So if you look at here, from 16 to 28, we have kind of assigned a bucket. So anybody who has very high scores will be allotted a 16% APR. Similarly, anybody with a very low score will be assigned to a 28% APR. So what's important here is not just the pipeline. You can interact live over here and see how the data is correlated. So I am clicking on 28. I can see that it is related to cluster number 2. So this kind of gives me a live insight of the data over here. So in this way, basically, the data is evaluated in real time, stored into a storage system, as well as pushed back to Kafka, so that you can respond to the customer in real time from the queue. And here, the dashboard, one thing I did not cover is, this is not a static dashboard. This dashboard could again link to internal systems, and you could actually connect to something like your Jira or your IVRS system or your ServiceNow ticket request. You could connect to internal systems and take actions over here. So as a user, if I have deferred records, I could see all the records and make a decision and click on update and take a decision right on the dashboard. So just to summarize, all the pipelines where, from training to scoring, everything was automated. It kept running. As soon as the customer applied, all the decisions were taken in an automated fashion. Real-time integration was done. We integrated all the ML models in the flows, both in training and scoring. All the manual reviews, the dashboard that you see, all the decisions that people were taking on the dashboard provided as a feedback next time the training model was created in the pipelines. So, it was kind of, continuously evolving. It's not like one time you create the entire picture and it stays there. So every time the feedback loop was completed and the model kept on kind of evolving. So, I know this was fast. I hope you got a sense of what we accomplished, and if you have any questions, do drop by our booth. It's on number 400. We'll be happy to connect with you. Thank you so much.